Okay, so in this lesson we're going to be looking at the required practical number 4. Specifically, this is what it says you're supposed to be able to do. So it says investigate the variables that affect temperature changes in reacting solutions, such as acid plus metal, acid plus carbonate, neutralizations, and displacement of metals. Now, the one we're going to look at is neutralizations. However, clearly, you could have any of the other options there. Essentially, the methodology is the same. You're going to use a coffee cup calorimeter, so that's a polystyrene insulated cup, because that will keep your basically keep the energy in, and you will add the two substances, so acid and a metal, or an acid and a carbonate, or an acid and an alkali, or a metal and a metal solution, and you're going to measure the temperature change of that. Okay, so they're all very similar, but like I say, we're going to look at neutralizations today. Right, so we're going to be looking at the temperature changes required practical. There are a couple of videos on the online lesson plan which you need to have a look at as well. There's good old free science lessons, but the second one has got a guy who's actually literally walking you through how to do the practical, so please have a look at that one. The idea of this narration really is just to give you some clues for these questions on the right. If you think you can do those straight away, then you probably don't really need to listen to this. Anyway, let's have a look at the questions. So first one is looking at the chemicals provided, write a word and symbol equation. So hopefully you can see that we've got some hydrochloric acid and we've got some sodium hydroxide. So you've got your two reactants there. Now you should know that obviously hydrochloric acid is an acid. You should know that if it's hydroxide, it's an alkali, and you should know that acid plus an alkali makes a salt and water. So you then got to think about what salt you get from hydrochloric acid, and you might remember that gives you a chloride. So therefore your products would be sodium, chloride, and water. So you should be able to write the word equation for that. Symbols, well, hopefully you know hydrochloric acid, and that's obviously got hydrogen and chlorine in it. Sodium hydroxide, well, sodium, you can look these things up on a periodic table, all right, and a hydroxide tells you the other two elements in that, so you should be okay with that one. Okay, so this reaction is exothermic. Now, hopefully you know what that means. So exo, out, thermic, heat, so it gives out heat. Now, we're using a polystyrene cup, sometimes called a coffee cup calorimeter, and there's a good reason for that. If you think about what we're trying to do, we're trying to measure the energy change of this reaction that's giving out heat. So what's good about polystyrene, that means that we will make sure that we are measuring all of that energy change. Have a think about that. For number 3, if we want to investigate how that temperature varies when you change the sodium hydroxide in terms of the quantity added, all right, so we need to think about variables. So the independent variable is the thing you're changing, all right, the dependent variable is what you're going to measure, and control variables are things that stay the same. Sometimes, well, commonly actually, you will now see on the new papers they refer to you writing an experiment that gives valid data. That basically means you have to write down your control variables. So if we have a look at this, it says you want to investigate how the temperature of the reaction varies. Right, okay, so we're going to be measuring the temperature of the reaction when sodium hydroxide is added. Okay, so we're looking at adding different amounts of sodium hydroxide. So the thing that we are changing is going to be the volume of sodium hydroxide. So that would therefore be the thing you're changing. The thing you're measuring is going to be the temperature. And some other things that would need to stay the same, well, if you have a look on here, there's a little clue there and there. That might be a clue as to one thing that's got to stay the same. You might even notice there's a measuring cylinder snuck behind there as well, so that's another clue as to what might have to stay the same. And finally, it says, the student predicted the more sodium hydroxide is added, the higher the temperature will be. Right, so this is an interesting question, because if you think about that, it seems a logical response. But if you then think back to your chemistry knowledge, you should know that when you add two chemicals together, right, they will react, and they will react in a specific ratio, like in the balanced equation. So up to a point, if you keep adding sodium hydroxide, it's going to basically react with more hydrochloric acid, and therefore the temperature should increase. However, there will come a point where the sodium hydroxide, you'll end up adding more than necessary to react with that. So there will be, you might remember this word, excess sodium hydroxide. So at that point, there's no more acid for it to react with. So you're just adding more and more sodium hydroxide. There's no more acid. So actually, there will come a point where the temperature will stop increasing due to the fact that the hydroxide is now in excess. Okay, so graph plotting is something that you're likely to have to do in a lot of your exams. So we just chatted about the fact that as the volume of sodium hydroxide increased, the temperature is likely to increase, and you can see that that's happening here. But then you'll begin to notice that at this point it then starts to go down, and if you listen to the last slide, you will remember that we were chatting about the fact that at that point sodium hydroxide must start to be in excess, as in there is more sodium hydroxide than is required to react with the hydrochloric acid. So that extra sodium hydroxide essentially isn't doing anything. All it's doing is diluting the whole system and basically cooling it down. So you then start to get this decrease.